Okay, now we're going to move on to sp2. sp2, remember, has 3 things coming off of it. Since it has 3 things coming off of it, what that leaves open for is another p orbital to remain not as a hybrid, but just as an actual p orbital. So let's take a look to see what's happening here. Let's say that this is our carbon, what do we call that? Ethane. So here's our ethene bonds right here. This right here is our carbon right here. It's going to bond with the other carbon that's over here. So what I have here, I have an s orbital with a hydrogen. S orbital with a hydrogen. Now the other carbon is going to have a similar bond coming back the other way, because these two are just basically mirror images of each other. So we have overlap there. Okay, so on this side we will also have hydrogen and hydrogen. So if we look at our bonds, what I have drawn so far has been just our sigma bonds. So we have sigma bonds, so single bond, single bond, single bond, and single bond. This one right here is also a sigma bond. A lot of times people will miss that as being a sigma bond, but that's one. Okay, what we're lacking is that second bond. What makes that bond happen? We'll actually be able to see this a little bit better once we get the molecules out and we actually make them with the models. But like I said, it actually has a p orbital. So let's make that p orbital come through here. So we have a p orbital that rises through there and through the bottom. Oop. Up and through the bottom. Okay, now there is no way for these two things to touch each other here. It just doesn't happen. Okay, so if we start thinking about it, which bond is going to be stronger? Our first bond, which has actually got overlap, or these bonds, which they're kind of just reaching out and they've got an attraction, but they can't touch each other. Okay, that's why second bonds, that double bond, is really easy to break because there's not a lot of attraction there. It does shorten it and makes it this a lot closer, but it doesn't have the attraction. Okay, this little fillers out here, those are called pi bonds. Now I'm not going to write it in both places because this is one pi bond. So if I were to look at this, I have sigma, 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 5 sigmas, and 1 pi bond in my double bond. So let's go back and look and see what this molecule looked like again as a stick model, as us drawing it. Okay, we have an sp2 orbital, sp2 right there. Okay, the double bond, we have a sigma and we have a pi. We have a sigma here, sigma, and sigma. Okay, you'll see a lot of stuff like that as we go through and draw our stuff. Okay, so sp2 with an unhybridized p orbital. Okay, let's go ahead and go do our sp with no hybrids. All right, what we have here is going to be the sp orbital. So it's linear. We know it's going to be a straight line, but let's see how we get there and why we're there. For example, I threw up an element or a compound that's commonly known as acetylene. Ethine is the organic name for it. So here's my 2 carbons. I have a carbon here kicking out its orbital and a carbon over here kicking out its orbital. Now they look like p orbitals. Those are not p orbitals. That's the sp hybrid orbital. Okay, so I'm going to bond this carbon or hydrogen first. So let's go ahead and draw hydrogen in there. It is going to be an s orbital. And then I'm going to draw this hydrogen. It's going to be an s orbital. Okay, so what we've done is so far we've got carbon with a grand total of 5 electrons, and this carbon has 5 electrons. Now we've got one bond right here, I guess, so let's make that 6 electrons. Let's go ahead and overlap that so we can definitely see that they are bonded. Okay, so we have 6 electrons for the carbons. Let's get its other 2 ones. Okay, so it's sp, that means it's got 2 unhybridized p orbitals. Let's draw our p orbitals. One is going to go out the top, one out the top over here. And what they do is they send out their vibe. Okay, that is 1 pi bond. So that means at this point I am double bonded. Now we have to really think 3 dimensions right here. Okay, since I'm full going in the x direction and the y direction, let's go out in the z. So we're going to come out and work backwards as well. We're coming out and working backwards. They also are going to send out their vibe, working across. Okay, so if we went from single bond to double bond, a triple bond is going to squish in even just a little bit more. Okay, so this is another pi bond. So if I'm counting, what I see is I have a sigma bond over here on the H. I have 1 sigma bond here in the middle. I have a sigma bond out here on the edge. In the middle, I have 2 p orbitals that are unhybridized, so that means I have 1, 2 pi bonds. So every time I have a double bond, triple bond, I'm going to end up with pi bonds. 1 double bond is 1 pi bond, 2 is going to be, or triple bond is going to be 2 pi bonds. So we need to work more with the models. That's going to come in really handy. Make sure you're looking at the models and not just letting somebody else do it, because when you learn it, it's going to be a lot easier. All right, have a great evening. We'll see you guys tomorrow.